Hi, this is Janossy. This is the page lecture for page 16 in the Contemporary Computing Workbook. What we're going to talk about here is digital information organization. First, I'm going to talk about different types of files and what they contain, and then I'm going to talk specifically about text files that contain ASCII characters. Information in digital form. The important thing about this to remember is that we're dealing here with bits. Bits can be on or off, and collections of bits make up bytes. But in order for the information to be of any consequence stored in this form, both the person recording the information, or the computer recording it actually, and the person receiving the information and intending to read it, or the computer intending to read it, have to agree on the meaning of those bits. And that's the key to understanding these different formats, at least in a general form. Text files contain the kind of ASCII coding that you've become familiar with. The formats of these, that is how the bits formed into bytes and how the bytes are formed into larger collections of information, these have been standardized by the practices of what's known as traditional data processing that was commercialized in the 50s and was the mainstay of the use of computers all the way through the 1990s. The key to understanding how sound is recorded and captured in digital form is to understand that the sound wave intensity is sampled, and the values that are recorded of the intensity of the sound pressure wave are then used to reconstruct the sound wave by the equipment that plays the sound file. And we'll talk more about this in Unit 3 when you actually start doing some sound editing. Images are stored by dividing the image into millions of small cells called pixels, picture elements, and recording the light intensity of each one of those pixels. It's a little more complicated than that, because if we only recorded the light intensity as one value, we would be creating a black and white image. But if we filter that light to separate it into components of red, green, and blue, and we record an intensity value for each of those separate colors, we can reconstruct the color of the pixel by combining those colors in the same proportions in which they exist in the original image. To sum it up, images are formed of small elements named pixels. We store the values that represent the coloring of that pixel. And video is very similar to still image processing, except it has to be repeated very rapidly, 30 times per second. The eyes have a persistence factor. The cells at the back of your eye can't switch from one image to the next. They sort of have a little afterglow to them, and that blends the images together so that although there really are 30 separate still images, your eye and your brain work together to see them as moving images. So there you have it as far as the various types of information that are represented on page 16 at the top. These are some of the common formats of files that are indicated on this page for word processing, DOC and DOCX, various kind of sound files where the mechanism to create that particular type of file, such as an MP3, is designed to compress the audio information so that it stores in much less space, and various kinds of algorithms are used to do this. The same applies to image formats like JPEG and GIF, and to video formats, MP4 being the most common, AVI, MOV, WMV being various formats evolved either as industry standards or by vendors like Apple with MOV or Microsoft with WMV. In the next part of this video, I'm going to focus on text information, the type that was popularized and standardized through data processing activities in the first 30 years of the use of computers. This is based on the fact that we can represent characters. And now, folks, since I'm recording this in the backyard and there's some person next door setting up some equipment that's going to make a lot of noise, I'm going to try something new for the next part of this video. Instead of me narrating it, I'm going to put subtitles that scroll across the bottom, and they're going to express what I otherwise would have said. So get set for an experiment, because when somebody's putting his roof on next door to your house, it's not a good time to record a video.